day, everyone. Welcome to class again. We have started the series on statistics. We've talked about the group data, graphical presentation of data, where we talked about the pie chart, bar chart, histogram, the cumulative frequency curve. So today we shall move on to probability. Probability is also an extension of statistics. So probability mainly measures the degree of occurrence of an event. It is the likelihood that an event will occur. If I eat lunch every day, and let's say for 5 days I've taken Indomie 3 times, and the rest was rice, the other one was beans. I might want to know the probability or the likelihood of me taking Indomie the next day or again. So if I'm interested in that, I'll have to go back to the past record that I have and try to use it to estimate or find out the tendency of me eating Indomie again. So if we move on here, so let X be an event. Now event is just an occurrence. So if I'm interested in the probability of me eating Indomie this afternoon, then it means the event is the event of me eating Indomie. The event of somebody coming to class this afternoon or this morning is an event. So if X is an event, then the probability that event X will occur is given by P of X. Probability of event X. That's what P of X stands for. Hence, P of X is given by number of favorable outcome divided by total possible outcome. So if we don't have records, just like statistics is the science of collecting, organizing, summarizing, presenting, analyzing, and interpreting numerical data. It is as a result of a previous data or an information that we have that helps us to determine the probability or the tendency for which that event will occur again. So, like I said, if I have taken food 5 times, and out of the 5 times, Indomie, rice, and beans. If I'm interested in calculating or knowing the probability of me eating Indomie again, then I have to go and say the probability of eating Indomie, because that's my event, is number of favorable outcome divided by total possible outcome. Now, if I check my data, I realize that from the data I have taken lunch 5 times, and out of it, how many of it favors Indomie? 3. 1, 2, 3. So that is going to be 3 divided by total possible outcome is talking about total times which I have taken lunch, and that is 5. So the probability of me eating Indomie is 3/5. So that's explaining this definition. And this definition is essential and very important in every aspect of probability. Always note that probability of an event happening or occurring is the number of favorable outcome, number that favors that outcome, divided by the total possible outcome that we have. So definitely, probability is always in form of a fraction, where the denominator is bigger and the numerator is smaller. We could also express it in a decimal form, because this will give us 0.6. Then if we move on to the properties of probability, number 1 says summation P of X equals to 1. That is, if I add, don't forget that summation sign means addition. Summation, addition of my probability of x's must give me 1. Like now, if this is the probability of eating indomie, it gives me 3/5. Probability of eating rice will be how many favors rice? Number of favorable outcome. In this information, how many favors rice? Just 1. That will be 1 divided by total possible outcome, which is 5. Probability of taking beans will be also how many favors beans? 1 divided by 5. So if I decide to add all my probabilities together, that's what the first property is saying, that the summation of P of x is 1. So if I add probability of eating indomie, I'm using I for indomie now, plus probability of eating rice, plus probability of eating beans, it gives me 3/5 plus 1/5 plus 1 divided by 5. Taking the LCM, we have 5 as the lowest common multiple. So 5 and 5 is 1. 1 times 3, 3 plus 5 and 5 is 1. 1 times 1 is 1. And it's also 1. So this gives me 5 divided by 5. And that is 1. So the addition of all the probabilities, depending on what we are considering, is equals to 1. Also, 0 is less than or equal to P of x, and is also less than or equals to 1. What does this property tell us? It tells us that the probability cannot exceed 0 and 1. Probability can never be 2. Probability can never be minus 1. So probability lies between 0 and 1. So what does 0 means? 0 simply tells us that the event will not happen at all. The event will not occur. And 1 tells us that the event will surely happen. It is certain that this event will happen. So if the probability of an event is 1, then it's telling us that it is certain that this event will occur. Like now, students might be talking in the class that the lecturer is not coming, the teacher is not coming, we've not seen him. And someone asks, what is the probability of this teacher attending the class today? If somebody said it's 1, that means it is certain, it is sure that this lecturer or teacher will come to class based on probably past records, that okay, he has never missed the class. The person will say he will surely come. So that is the probability that the lecturer or the teacher will come to class is 1. So it's a sure event that the teacher will come. And if the person said 0.5, then that means it's 50-50. It's either he comes or he doesn't come. It's on a 50-50 basis. And if it says it's 0, definitely it will not even happen at all. The lecturer will not come to class. So that's what it means. Events could be, the third one, P plus Q equals to 1, is still actually telling us that the addition of all the probabilities is 1. But in this case, this one is used when we are talking about probability of success, probability of failure. Most of the time, it's always in those two ways. But this, we can get other events and add them together. But here, if I'm interested in the probability of a hunter shooting his catapult at a bird, that is the success. Probability of shooting or eating a bird when you fire the catapult. So the probability that he will not eat it is just the failure. So that is, if you had probability of the success, probability of the failure, it also must give us 1 if you had them together. So if I'm interested in probability that somebody will die, that's the success, because that's what I'm interested in. So the probability that you will not die is the failure. Just like opposite, word and opposite. So if it's not going to die, then we just take this from this. Our P will be 1 minus Q. The third one, like I was saying, P plus Q equals to 1. So this is probability of success, that is probability that the event will happen. And Q represents the probability that the event will not occur, will not happen. So from this, if I'm interested in knowing the probability that the event will happen, then I could extend this equation to this. Take Q out of the equation, of this side to the other side. We have P equals to 1 minus Q. And also, if I'm looking for Q, I take P to the other side. I have Q equals to 1 minus P. So this will help us when we get to events that has to do with this. I have a very good question. The question is, when I was talking about the numerator and denominator, the denominator of a number is the one below and the numerator is the one above. So in this case, 3 is the numerator and 5 is the denominator. So my 0.6, 5 out of 3 is impossible because 5 is bigger than 3. So that's 0 point, and you add a 0 to this, making 30. So 5 in 30 now is 6. Events could be mutually exclusive or independent. That is, we could have mutually exclusive events and we could also have independent events. Now, what are mutually exclusive events? The mutually exclusive events, like let me say it this way, 2 events are said to be mutually exclusive if the occurrence of one disturbs the other. If the occurrence of event A will prevent event B from occurring, then the 2 events are said to be mutually exclusive. For example, I want to chew gum in my mouth and also sing. I can't do both. I want to wash my clothes. The event of washing my clothes and sweeping is either I'm using my hand to wash my clothes or I'm using my hand to sweep. It is not possible for me to be doing the 2 at a time. So in this case, the 2 events are mutually exclusive. The event of washing the clothes and also sweeping the floor. That means I have to leave one for the other. So in cases like this, most of the time, in fact, mutually exclusive events lead us to addition of probability. So when 2 events are mutually exclusive, it is either this one occur or that one occur. Another example is this. What is the probability, or let me say, if I throw a die, what is the probability of me having a 3 or a 5? On a die, 3 cannot occur, 3 and 5 cannot occur at a time. It's either the face gives me 3 or the face gives me 5. So for that, the 2 events are mutually exclusive. What do? I have to add their probabilities together. So in this case, the mutually exclusive will lead us to addition of probability. Then independent events. Now, when 2 events or more can occur individually without disturbing each other, then they are said to be independent. I could be singing and still be sweeping. So the event of singing does not disturb the event of sweeping. So both events are independent. Thus, I can say I am sweeping and singing at the same time, simultaneously. So independent events also leads us to multiplication of probability. So when we have independent events, we most of the time multiply them together, and when we have mutually exclusive events, we add them together. We have an example here to deal with. There are 9 identical balls in the bag. 3 of them are black, 2 are green, and the remaining are red. If a ball is drawn at random, what is the probability that it is red. That's number 1. Number 2, black. Number 3, green. Number 4, not green. So, if we go by the definition earlier, probability that an event will occur is number of favorable outcome divided by the total possible outcome. We are going to always use this information. So, if I'm interested in the probability of picking a red ball from the bag, then I just go to the bag, count how many red do I have. 1, 2, 3, 4. So how many favors red? 4 favors red. Then the total possible outcome is the addition of all the balls in the bag, which is 9. So probability of picking a red ball is 4 divided by 9. Number 2, probability of picking a black ball. How many favors black? We have 3 black balls divided by the total number of balls in the bag. So pick this, 3 divided by 9. So by extension, 3 can divide 9. 3 here 1 and 3 in 9 is 3. So that's how I got 1 divided by 3. Probability of picking a green ball, the same way, 2 favors green. There are 2 green balls in the bag. So favorable outcome is 2 and total possible outcome is 9. So the next one says probability of not picking a green ball. That's what it's saying. Don't forget, if a ball is drawn at random, what is the probability that it is not a green ball? Now, don't forget that we have to pick just one ball. And if I'm picking one ball and it's not a green ball, so it's either it is red or black. If the ball I'm picking is not green, definitely it's either it is a red ball or a black ball. So what kind of event is this? From the explanation earlier, the event of picking a red ball or a green ball or a black ball, they are mutually exclusive, because if I picked a red, I can't pick a black ball, and if I have picked a black ball, I can't also pick a red ball. So it's either it is a red ball or a black ball. Don't forget again, if it is not green, it's either red or black. So probability of not picking a green ball is either going to be probability of picking a red ball or probability of picking a black ball. So I said when they are mutually exclusive, it simply by extension goes to addition of probability. So the two events, probability of the two events, we had them together. So probability of picking a red ball, we have done that earlier. So anywhere we see or, either, neither, they are talking about mutually exclusive events. Either this or that, because if this is happening, the other will not happen. So we add them together. And when it is and, that is when the two events can occur at the same time, then they are independent events. So we multiply them together. So here, probability of picking a red ball is 4 over 9 plus probability of picking a black ball is 1 divided by 3. So if we simplify that, 9 is the LCM. 9 out of 9 is 1. Then times 4. 4 plus 3 in 9 is 3. 3 times 1 is 3. So the answer is 7 divided by 9. So that's probability of not picking a green ball. Now, when I was talking about the properties of probability, I got to a point where I said P plus Q equals to 1. This question says not green. So if I'm interested in picking balls that are not green, it's just the opposite of picking a green ball. So if P represents probability of picking a green ball, then Q, don't forget that Q represents probability of failure, that it doesn't happen. So probability of not picking a green ball. That was what my Q will be. And I said that P is 1 minus Q, and also Q is 1 minus P. So in other words, for me to get probability of not picking a green ball, what I just do is say probability of not picking a green ball, which is now standing as my Q, is equal to 1 minus probability of picking a green ball. And I have done that before. Probability of picking a green ball is 2 divided by 9. So that's 2 divided by 9. If I go on and find the LCM of this is still 9. 1 in 9 is 9. 9 times 1, 9 minus 9 in 9 is 1. 1 times 2, 2. So which is still 7 divided by 9. What is the probability that they are both 1 red, 2 black, 3 green, 4? What is the probability of picking a red first? 5, a red and a black. 6, 2 different balls. Now, A with replacement, B without replacement. So such questions can come either with replacement or without replacement. So if we want to answer this whole question, we'll take A first with replacement. So everything I'm going to do here, will be with replacement. Number 1, probability of picking 2 red balls. If 2 balls are drawn at random, one after the other. So I dip my hand inside the bag, I pick the first one red. That means I returned it and picked it again. The second one is also red. So what's the probability of picking 2 red balls? And the word random is saying that we should not be biased in this case. It's either you close your eyes and just pick one. You can't open your eyes and pick it. If you want to take meat in the pot and you are looking for the bigger one, then you are not picking that random. But if you really want to pick that random, close your eyes and pick anyone. Anyone you pick is your meat. So that's randomness. So in this case, it must be random. So we pick 2 red balls. So that means I'm picking a red and a red. So that will give me probability of picking a red ball. Don't forget the box or the bag. We have 3 blacks, 2 green balls, and 4 red. Since they said the remaining are red, so 2 plus 3 is 5, subtracted from 9 gives us 4. So if I pick a red first, it's going to be 4 divided by 9, multiplied by. If I returned it, we still have 4 balls, 4 red balls. So it's still going to be 4 times 9. So that's what replacement means. That's after picking the first ball, I put it back before picking at random again. So 4 divided by 9 times 4 divided by 9. That gives us 16 divided by 81. Number 2, what's probability that they are both black? Probability of picking a black first and a black next. So probability of picking the black ball will be 3 because you have 3 favoring black divided by 9. So if I return it back into the box, into the bag rather. So the black first, then the black next. The first one 3 over 9 multiplied by 3 divided by 9 too. So if I divide 3 here 1, 3 in 9 here 3. 3 here also is 1, 3 in 9 here is also 3. So 1 times 1 will give me 1, 3 times 3 will give me 9. That's the probability of picking 2 black balls. Then the next one, number 3, that both of them are green. Also, we go to 2, which is, we have 2 green balls. 2 divided by 9 here, multiplied by the other one is also green, 2 over 9. So 2 times 2 is 4, 9 times 9 is 81. As long as we have it in this simplest form, I can leave it that way. Number 4. What is the probability of picking a red first? It is a red ball first. It's either we have the red first, the black second, or the red first and the green second, or the red first and the red again second, since we have 4 reds. So, if we proceed, of picking a red, we have 4 divided by 9, multiplied by 3 divided by 9, plus, of picking a red again, 4 divided by 9 times 2 divided by 9, then plus 4 divided by 9 multiplied by 4 divided by 9. So by simplifying that, 3 here, 1, 3 in 9 is 3. So 4 times 1 is 4, 3 times 9 is 27. Plus 4 times 2 is 8, 9 times 9 is 81. Also 4 times 4 is 16, 9 times 9, 81. So if you find the LCM of that, we have 81. 27 in 81, 3. 3 times 4, 12. Plus 81 out of 81, that's 1, times 8, 8. Then 81 in 81 is 1, 1 times 16, 16. So if you add these two, that's 20. 20 plus 16, that's 36. So if I simplifying this, 9 here is 4, and 9 here is 9. So that's how I got 4 over 9. Number 5. Number 5, a red and a black. That is, the 2 balls, we have a red and a black. Now this time, they're not saying a red first or a black first. So it's either we have a red first, black second, or black first, red second. AB is also BA. A times B, 2 times 1 is 2, 1 times 2 is also 2. So it could be red first, black second, or black first, red second. Then we move on. Probability of picking a red ball is 4 over 9 times of picking a black ball, 3 over 9, plus 3 over 9 the black ball first times 4 over 9 the red ball second. So by simplifying, 3 here 1, 3 in 9 is 3, so 4 times 1 is 4, 3 times 9, 9 times 3 is 27. The same thing happens here, 3 here 1, 3 here 3, so 4 times 1 is 4, 3 times 9, 27. So the LCM, 27 here is 27, 4 times, that's 1, 27, 27 is 1, 1 times 4, 4, plus 27, 27 is 1, 1 times 4, 4. So 4 plus 4 is 8 divided by 27. The last question under with replacement is probability of picking 2 different balls. Now, if I'm picking 2 different balls, it's either I pick a red first, black second, red first, green second, then a black first, green second. But in this case, that's when the red is first. So we have to reverse it also. After these 3, or black first, red second, green first, red second, and also green first, black second. So now we have 6 possible outcomes. For the red first here, for the of picking a red ball, 4 over 9, times of picking the black ball, 3 over 9. Goes like that, 4 over 9 times 2 over 9, 3 over 9 times 2 over 9, 3 over 9 times 4 over 9, 2 over 9 for green here, times 4 over 9 for red, then 2 over 9 for green, 3 over 9 for black. We have 4 over 9 times 3 over 9. So if I divide this, 3 here 1, 3 in 9 is 3. So 4 times 1, 4, 9 times 3, 27. 4 times 2, 8, 9 times 9, 81. Here also I can divide 3 here 1, 3 in 9, 3. So 1 times 2 is 2, 3 times 9, 27. So I go further to this part, 3 here 1 also, this is 3. 4 times 1, 4, 3 times 9, 27. Here 2 times 4 is 8, 9 times 9 is 81. And also 3 here 1, 3 in 9, 3. So 2 times 1, 2, 9 times 3, 27. So the rest is for us to find the LCM, and the LCM is 81. 27 in 81, 3, 3 times 4, 12. 81 in 81, 1, 1 times 8, 8. 27 in 81, that's 3 again, 3 times 2, 6. 27 in 81, 3, 3 times 4, 12. 81 in 81, that's 1, 1 times 8, 8. 27 in 81, 3, 3 times 2, 6. So we had everything here together. It gives me 52 divided by 81. That's the probability. The B part of the question says without replacement. So in this case, we have to repeat the whole question, but now considering that it is without replacement. And what does this without replacement mean? It means that after picking the ball, it does not go back to the bag. We are not replacing it. That's what it means. So the first question says, what's the probability of picking 2 red balls? So the first one is red, the second one is red. Here now, probability of picking a red ball, don't forget we have 4 red balls. That's 4 divided by 9 times. Now, red has reduced. Because if I pick one, I did not return it. And I have 3 red balls. So that's going to give me 3 divided by 8. Because the total ball has now reduced to 8. Again, if I picked 1, this is now 3. So that's 3 over 8. Then the 8th part is 3 plus 2, which is 5. 5 plus 3, and that is going to give us 8. So that's how I got 3 over 8 here. So just simplify. 4 here 1, 4 in 8, 2. 3 here 1, 3 in 9, that's 3. So 4 here 1, 4 here 2, 3 here 1, 3 here 3. So 1 times 1 is 1, 3 times 2 is 6. The next one of picking 2 black balls. If I pick the first one, that's 3 over 9. It has reduced, we have 2 more black balls, so that's 2 over 8. If I divide this, 3 here 1, 3 in 9, that's 3. 2 here 1, 2 in 8, that's 4. So 3 times 4 is 12, 1 times 1 is 1. The other one, 2 green balls. Green, I pick the first green, 2 over 9. Now we have 1 green more, so that's 1 divided by 8 because the total has also reduced. 2 here 1, 2 in 8, that is 4. So 1 times 1 is 1, 4 times 9 is 36. So we move on to the fourth question, picking red first. So if you are picking red first, we have done this before. So it's just the same thing, but now we have to consider that we are doing it without replacement. So red first, black second, or red first, green second, or red first again, because we could also pick another red ball. So in this case, 4 over 9, then 3 over 8. Why? Because 3 black balls is still there. It is only the red that would have reduced. So we have 3 black balls divided by 8 in total. Plus, this is 4 over 9, green ball 2 over 8. The total would have reduced, but the green ball is still 2. 4 over 9, that is, R is 4 over 9, then multiplied by 3 over 8, because the red has reduced to 3, and the total also has reduced to 8, just like we have here. Then to simplify that, we have, just simplify again, 4 here 1, 4 here 2, 4 here 1, 4 here 2, 3 here 1, 3 here 3. So 1 times 1 is 1, 3 times 2 is 6. 4 here 1, here 2. So 2 can also cancel 2 here. So that's 1 divided by 9. Here also 4 here 1, 4 here 2, 3 here 1, 3 here 3. So that's 1 divided by 6. 1 over 6 plus 1 over 9 plus 1 over 6. So the LCM is 18. 6 in 18, that's 3. 3 times 1, 3. 9 in 18, that is 2. 2 times 1, 2. 6 in 18, that is also 3. 3 times 1, 3. So if I have this together, 3 plus 2, 5. 5 plus 3, 8. So that's 8 over 18. 2 in 18, that's 2 in 8, 4. 2 in 18, 9. So that's how I got my 4 over 9. Number 5, what's probability of picking a red and a black ball? So just like I said earlier, it's either it is red first, black second, or black first, red second. So now we are considering without replacement. So here I have 4 over 9 multiplied by 3 over 8 plus black ball 3 over 9 multiplied by the red is 4 divided by 8. So if we simplify that, 4L1, 4 in 8, 2. 3L1, 3 in 9, 3. So 1 times 1 is 1. 3 times 2 is 6. Plus, the same thing goes here. 4L1, 4 in 8, 2. 3L1, 3 in 9, 3. So 1 times 1 is 1. 3 times 2 is 6. So finding the LCM, 6 is the LCM. 6 in 6 is 1. 1 times 1 is 1. The same thing, 6 in 6 is 1. 1 times 1, 1. So that gives us 2 over 6. And by simplifying further, 2L1, 2 in 6 is 3. That's 1 divided by 3. And the last question, what's probability of having 2 different balls? So I've explained that too. I'll explain again. It's either it is red, black, red, green, or black, green. So that is when we are picking the red first here, black second, red first, green second, black first, green second. So if we interchange that now, we have black first, red second, green first, red second, then green first, black second. So by simplifying, 4 over 9 for red times 3 over 8 for black plus 4 over 9 for the red balls times 2 over 8 for the green ball. 3 over 9 for the black ball, 2 over 8 for the green. Just like that, 3 over 9, 4 over 8 for this, 2 over 9, 4 over 8 for this, 2 over 9, 3 over 8. So we simplify that further. We have 4L1, here 2, 3L1, here 3. So that gives us 1 times 1, 1, 2 times 3, 6. Also, 2L1, 2L4. 4L1, 4, and cancel 4. So that's 1 divided by 9. Here also we have 3L1, 3L3, 2L1, 2L4. So that's 1 times 1, 1, 3 times 4, 12. So if we simplify this, this is 3 over 9 times 4 over 8, which is also 4 over 9 times 3 over 8. This gives us 1 over 6. This also gives us 1 over 9. And this one finally, 2L1, here 4, 3L1, here 3, which is still 1 times 1, 1, 3 times 4, 12. So LCM is 36. So 6 can go in 36, 9 can go in 36, 12 can also go in 36. So 6 in 36, 6, 6 times 1, 6. 9 in 36, 4, 4 times 1, 4. 12 in 36, 3, 3 times 1, 3. 6 in 36, 6, 6 times 1, 6. 9 in 36, 4, 4 times 1, 4. And 12 in 36, that is 3, 3 times 1, 3. So if I had all this together, we have 6 plus 6, that is 10. 6 plus 6, that's 10 again. So that's 26 altogether, divided by 36. If I divide this by 2, I have 13. Divide this by 2, I have 18. So that's how I got my final answer to be 13 divided by 18. I have a very good question, and the question is, what is the relevance? What does this without replacement, with replacement, what does it do for me? How does it help me? Well, when we do calculations or even mathematics generally, it helps our logical reasoning. But in this case, when we are doing with replacement, it gives us a sense of when I pick a ball, I replace it back, then my counting still remains the same. What I'm doing has not changed. If I want to pick green balls now, I just consider that, okay, I have 2 green balls divided by the total. If I want to deal with the red, I have 4 red balls divided by the total. But now when we move to without replacement, it helps us to also have a sense of awareness, and we need to be careful also in doing whatever we want to do in life, so that we don't make unnecessary mistakes. We have to pay attention to details to be able to remember or have at the back of our mind that now I'm doing without replacement. If I'm doing without replacement, I have picked a ball out of 9 balls. Normally, when we are just thinking casually and not being careful, we may just think, okay, I've picked it. What is the probability of now picking another ball or another red ball if I have picked a red ball earlier? Now the red ball has reduced. So in the case whereby 5 lecturers are to attend the meeting and 1 already is around, they now asked, what is the probability? Let's say we have 3 lecturers that are female, 2 male. What is the probability that a female lecturer, the lecturers will be around, or the female lecturer will come? Now we have 1 lecturer which is a male around already. We have 4 lecturers who are not around. So 3 females are not around yet. So probability that the female lecturers will come around is now we have 3 females that are supposed to come and 1 male that has not even come at all. So now our probability has become 3 divided by 4 and not 3 divided by 5 again. If the man was not around, we have 3 female and 2 male. What's the probability that the female lecturers will come? That is going to give us 3 number that favors the female lecturers divided by 5 total number of lecturers. But now we should have that back of our mind that 1 of the lecturers is around already. So we now have 4 lecturers left. What's the probability that the female lecturer will come? Then we have 3 divided by 4. So that helps us to pay attention to details and to also think logically too.